Hello scholars, welcome back. Today we're going to be looking at algebraic fractions. We're going to be dividing and multiplying. So we did a video on adding and subtracting algebraic fractions. This time around we're multiplying and dividing. We're using the same principles though as we do when we're multiplying and dividing regular fractions. So remember, if we are multiplying a regular fraction, we would first try to see if we can reduce the fractions by finding common factors that can divide into the numerators and denominators. Simplify the fractions as much as possible, and then we multiply the numerators, multiply the denominators, and again check to see if we can reduce the fraction. Same thing we're going to do for the algebraic fractions. For division, remember, dividing fractions, you retain the first fraction, you change the division to multiplication, and you invert the second fraction. So remember, to divide by a fraction is the same as multiplying by its inverse. So we change the multiplication and invert the second fraction. That's the same thing we're going to be doing for the algebraic fractions. So the main difference is that these fractions have variables involved. They have letters representing unknown quantities, but we're going to treat the fractions just the same way as regular fractions without variables. Alright, so here we have x over y times 4y squared over 9x. So we're going to see what can be cancelled out, what can be reduced. So this x can cancel out that x. This y can cancel one of those y's. So what we're left with then, in the numerator we're left with 4y, and in the denominator we're left with 9. And 4/9 cannot be reduced any further. This is our final answer, 4y over 9. So we have p squared q to the 4th power over r squared times r to the 5th over q to the 8th. Remember, when we are dividing, algebraic terms that have powers, right, we're actually subtracting the indices once the variables are the same. Alright, so the r squared, we can take 2 out of the r fifth, and that leaves back r to the 3rd power. So we just subtract 2 from 5. They both have r as the base, so to divide we subtract the indices, the powers. Right? So we took 2 r's out of the 5 r's, that leaves 3. For the q, so that's q to the 4th, and we can get 4 out of that. So 4 remains. And there's no p in the denominator. So what we have p squared r cubed in the numerator and q to the 4th power in the denominator. Alright, here we have 3 sets of fractions. Okay, 3 sets. We're going to cancel as much as we can. So the b squared takes out 2 from that. And this b will take out 1 out of that. So 1b is left. For the y, well, that y cancels that y. In terms of the coefficients, 5 goes into itself once and into 10 twice. Alright, I think that's about it in terms of reducing. So in the numerator, we have our 15 still. We have b, and we have this 1x times this x, that's x squared. We have our y, and in the denominator we have a 2. And the 15 and 2 cannot be reduced any further, so this is our answer. That's our final answer. Alright. Alright, so 6x to the 5th over 10y to the 4th p times 5y p cubed over 8x squared. Checking the coefficients, 5 can cancel 10, 2 can cancel 6. For the x's, the x squared can take 2 out of that. The p can take 1 out of that p. And this y can take 1 out of that y. So finally we're left with a coefficient of 3 and x cubed p squared in the numerator. In the denominator we have 8 and y cubed. And the 3/8 cannot be reduced. That's as simple as it gets. So that's our final answer. 9ab squared over 6xy to the 4th times 12x fifth y over ab to the 4th. Alright, in terms of coefficients, the 6 cancels the 12. So we have a 2 there. This a cancels that a. This b squared will take 2 out of the b to the 4th. This y will take 1 out of that y, leaving y cubed. And this x will take 1 out of that, leave 4. So finally, 9 times 2, that's 18. And we have an x to the 4th. In the denominator, we have b squared y cubed. Right? So that's as simple as we can make it. Alright, 24x over 40p cubed times p squared q cubed over 12x to the 5th. In terms of coefficients, the 12 can go into the 24 twice, and 2 can go into 40 20 times. This p will take 1 out of that p squared. This q will take 1 out of the q cubed, leave q squared. This x will take 1 out of the x to the 5th, and leaving x to the 4th power. So finally, we have, in the numerator, we have p q squared, and we have 20 times, well, 20 and x to the 4th. Okay, so we're halfway there. We have 12 problems and we're at number 6. So the remaining problems have to do with division. So remember, when you're dividing fractions, retain the first fraction, change the division to multiplication, and invert the second fraction, right? Because to divide a number by a fraction is the same as multiplying that number by the inverse of the fraction. So we are retaining the p squared m over xy to the 4th. Change the division to multiplication. Invert this. So that's what it becomes. The inverse. And now we carry on as if we had been given this as a multiplication problem, right? So p squared takes square out of that, so p is left. M will take 1m out of the m squared, leaving m. The y squared will take 2 out of the y to the 4th. And x will take 1 out of that, leaving 2. So finally, in the numerator, we have x squared, and in the denominator, we have p. So let's put them in alphabetical order. We have m, py squared, right? Usually we try to maintain alphabetical order with our variables as much as we can. So I just rearranged, put in the m, then the p, and then the y. Alright, so again, we rewrite, maintain the first fraction, change the division to multiplication, invert the second fraction. 10 goes into 40 4 times, 4 goes into 16 4 times, and 4 cancels 4. Okay, so we have just coefficients of 1 now working with. Alright, so for the variables, this x cancels 1 out of that, leaving x squared. That y cancels 1 out of the y squared. So finally, in the numerator, we just have 1. Because remember, each of these would cancel to leave 1. So it's 1 over, in the denominator, we just have the x squared and y. So it's 1 over x squared y. That's all we're left with. Okay, so here we retain the first fraction. Remember, we're dividing fractions. We retain the first one, change the division to multiplication, invert the second fraction. Okay, so let's see what we can do in terms of reducing the coefficients, the numbers that are in front of the variables. Okay, so 2 into 6, 3, 2 into 14, 7, 2 into 6, 3, 2 into 10, 5. And in terms of the variables, this x will take 1 out of that, leave 5. And that, well, this p will take 1 out of the p, leave just p. So in the numerator, we have 3 times 3 for the coefficients, right? 3 times 3, that's 9. 7 times 5, that's 35. On the bottom there. And we don't have any variables left in the denominator. We have some variables left in the numerator. So we have p, q to the 4th, and x to the 5th. Right? So we multiply our coefficients. These are coefficients, multiply them. And we rewrite the variables that we have remaining. Alright, so we have 3 problems left. These 2 are multiplication, but remember this is a division. So for this, we're going to change the division to multiplication and invert, just like we normally do. So we retain the 7xy over 10p. We retain the 14pq over 5x squared y. But the division becomes multiplication and we invert this fraction. So the fraction that follows the division sign is inverted, the reciprocal. It is reciprocated. So let's see how we can reduce the variable, the coefficients now. So the 10 and the 20 will cancel out. 2 can go into 10, 5. For the coefficients, we can't simplify any further. Alright, so let's see for the variables. So this x will cancel that x. This y will take 1 out of that y, leave squared. This p will cancel that p. I believe that is it. I believe that's it. So in the numerator, we have 7 times 14. Okay. 7 4 is 28. 7 1 7 and 2 9. And the only variable we have left in the numerator is a q. For the denominator, we have 5 times 5, that's 25. We have an x squared, and y times y squared, that's y cubed. So it's 98 cubed over 25 x squared y cubed. Alright, so for number 11, we're retaining the first fraction, and we're changing the division to multiplication, and we're supposed to invert the second fraction. Now remember, this is 8RT over 1. We didn't have to write the 1, but now that we're going to reciprocate it, now that we're going to find the inverse of it, we must indicate that there's a 1 now at the top. See that? So it was 8RT over 1, and we reciprocate it to 1 over 8RT. So now we see reducing the coefficients, 2 into 6, 3, 2 into 8, 4. This r cancels 1 out of the r squared. This t cancels 1 out of the t to the 4th. So in the numerator then, we have a coefficient of 3. We have a r. We have t to the 3rd power. And in the denominator, we have 5 fours, 20. Alright. Finally, we have 16 over 1 times y over 4x squared. We are reciprocating the second fraction, inverting the second fraction, because dividing by a fraction is the same as multiplying by its inverse. So now we reduce 4 and 16, and that's pretty much all we can do. So in the numerator we have 4y, and in the denominator we have x squared. And that is our final answer, and that's the final problem we have in the multiplication and division of algebraic fractions. So if you have benefited from this video, you know I appreciate when you say thank you. It's only fair. I've put out the effort. Just say thank you, miss. And share the video to as many persons as you can, so they can benefit as well from the information. And if you see where there are some topics that we have not covered in our catalog as yet, just drop a comment to let me know which topic you'd like me to speed up, because we're going to do all the topics eventually. But if you haven't found that particular topic you're looking for as yet, let me know and I'll do that quickly for you. If you haven't subscribed to the channel, please do so now, and tell others about the channel so they can benefit. So my scholars, I will see you in the next video.